Welcome friends, in lecture 3 standard 9th lesson 1st, that is matter in our surrounding. In this particular lecture we are going to take the topic of can matter change its states. So I would say the answer is yes, the matter has the capability to change its states. As I told you, there are 5 states of matter including solid, liquid and gas as BEC and plasma, but we are going to discuss for 3 states of matter, that is solid, liquid and gas. Now the effect of temperature, how it affects basically in change in states of matter. We will take pressure later on including temperature. First we are going to study how the temperature affects basically the change in state. Now as an experiment, as you are seeing that the ice is taken inside the beaker and it is heated, right, and the molecules of the ice are gaining heat energy. In absorbing the heat energy, you are able to see the temperature is 0 still, but the heat energy is absorbed by these ice molecules and these molecules are gaining kinetic energy. Kinetic energy, that is a movement of the particles. Once they are capable of moving, with these particles capability increases, they break down the bonds due to the supply of the heat and they start getting detached from their surrounding atoms, that is they start moving freely. Now as this particle starts moving freely, this particular entire solid structure, you are seeing that it started getting into conversion into liquid state. So what is the melting point? Basically is nothing but a solid melts into liquid due to gaining of the kinetic energy, and at 1 atmospheric pressure, obviously without change in temperature, that is whatever the minimum temperature it holds. Like in case of water it is 0 degree Celsius, so it remains 0 degree Celsius only. With except than 0, you are not going to find anything as 1 degree, and still you are going to find ice, because at 0 degree Celsius all the solid, if you are giving up the heat energy, is going to absorb the kinetic energy and convert itself into liquid state. That is called as its melting point. Right now, one more thing you are able to see, you have been seeing that the ice is gaining the energy. This particular energy at 0 degree Celsius only, the heat is going on absorbed. This particular energy is called as latent heat. Now what is basically latent heat? So I would describe in the form of a definition, that the amount of heat energy that is required, to change 1 kg of solid into liquid at 1 atmospheric pressure without any rise in temperature, that is at its melting point. Now without any rise in temperature, you are able to see at 0 degree Celsius only, without any change, the ice has melted. So the amount of heat energy that is absorbed is called as latent heat of fusion, which suggests that there is no change in temperature but there is change in state. Now before that it was gaining at amount of heat energy, suppose it was -5, suppose for an example, and it went from -5 to -4, -3, -2, -1. In other areas also where the ice is and the surrounding temperature is very low, it going on gaining energy, that is particularly called as a specific heat. That is not counted. When the temperature is changing and it is gaining the heat energy, is called as a specific heat. But what is a latent heat? Is nothing but the amount of heat energy absorbed, but there is no change in temperature and there is a change in state. The state is changing, that is from solid to liquid state, that is called as a latent heat of fusion, right. Going furthermore, you are able to see that the temperature is rising in the whatever the experiment that is being done, and you are able to see that now the water is getting heated and that above the temperature is shown that it is going on rising and it reaches to 100 degrees Celsius. Now when you are seeing that the water is reaching to 100 degrees Celsius, you see the bubbles coming out, right, from the water, and it is slowly, you are in the form of an gas, you are able to see the steam. That is what it is showing, that the stage the liquid boils into gas, liquid boils, that is amount of energy gain, kinetic energy gain, and the particles are no longer able to sustain into liquid fluid state also, so they are leaving each other and running away, gaining the kinetic energy, This state is called as a maximum temperature at which it cannot furthermore hold the bonding, that is intermolecular forces, and is called as a boiling point of that particular substance. Obviously the pressure surrounding is 1 atmospheric as we are counting. So I would say in the form of a define, the stage liquid boils into gas at maximum temperature and atmospheric pressure is called as its boiling point. Okay, going furthermore, you will be able to understand, suppose in the surrounding we are not allowing the gas to go also and we are still rising the temperature of the gas, so that is another specific heat, but that particular temperature the heat is been given, you are seeing that the Bunsen burner is burning and the amount of heat energy is absorbed by water molecules that are in the liquid state, but it is not showing any change in temperature. So the amount of heat energy that is required to change 1 kg of water, that is liquid state, into gaseous state at atmospheric pressure without showing any rise in temperature, that is any of the liquid substances, maybe petrol, diesel, whatever it is, into at its boiling point, that is at not showing any rise in temperature, is called as latent heat of vaporization. Latent heat of vaporization. The amount of heat, I would repeat, the amount of heat energy that is required to change 1 kg of liquid into gases, that is at atmospheric pressure without showing any rise in temperature, or you can say at its boiling point, is known as latent heat of vaporization. So what is this concludes, that ice was there and the temperature suppose was in minus, we reach to 0 degree Celsius, so specific heat, then latent heat of fusion where its state is changing from solid to liquid, again the rise in temperature, then it is again specific heat, and at 100 degrees Celsius again the state change and no change in temperature, state is changing from liquid to gas, that is steam, but no change in temperature, is called as latent heat of vaporization. So latent heat of fusion at its melting point and latent heat of vaporization at its boiling point. Fine, I hope so you understood this much by this particular experiment. Going furthermore, that is if the solid is directly converted, the solid is directly converted into its gaseous state without change in liquid state at intermediate, is called as its sublimation process. What is this particular process is called as sublimation, that is change of the state is there from solid to directly to gas. Many of the substances, so sublimation, this experiment I would show.
Chloride and chalk powder and put it in the evaporating dish. Now place an inverted funnel over the china dish. Heat the mixture. After some time, the ammonium chloride sublimates, that is, changes its state directly from solid to gas. So it gets vaporized while chalk powder remains in the dish.
And the reverse process is also there, that if the solid particles which has got vaporized and suddenly gets condensed into solid state, this particular is called as an deposition. Inside your book it has given sublimation only, reverse process also, but basically in higher studies you will use the word as a deposition. So the conversion of solid to gas is called as sublimation, and from gas to solid back it is called as a deposition. So this is what it shows, the change in states of matter. Fine, okay, thank you for this particular lecture.